Hi everyone, welcome to this lecture. So in this lecture, we will discuss another activation function, which is hyperbolic tangent function. So this is hyperbolic tangent function. We can see that this is the mathematical representation of the hyperbolic tangent function. Here we can visualize the hyperbolic tangent function. So we can see that its minimum value is -1 and its maximum value is +1. Sometimes it is considered as an extension of the sigmoid function because the minimum value of sigmoid is 0 and the maximum value is 1, but here the minimum value has been extended to -1. So its minimum value is -1 and the maximum value is +1. So this is hyperbolic tangent function and this is the mathematical equation. When we pass input equals to 0 to the hyperbolic tangent function, we get 0. So we can see that its output is 0 when the input is 0. And when we pass a negative value to the tangent function, we also get the negative value at the output. Similarly, when we pass the positive value, to the tangent function, we will get the positive value at the output of the tangent function. So it gives 0 at 0 and it gives negative value when the input to the tangent function is negative. Similarly, it produces positive value if the input to this hyperbolic tangent function is positive. So this is the property of this hyperbolic tangent function. So these are another properties of the hyperbolic tangent function. It is somehow okay for hidden layer. So why it is not good for the hidden layer? We will discuss it very soon. Okay, its minimum value is -1 and maximum value is +1. Okay, it doesn't have the biased average. This means that the average of its input and output is 0. If we remember in the previous lecture, we discussed the sigmoid function. The sigmoid function has biased output average because its minimum value is 0 for sigmoid and maximum value is 1. So if we take the average of 0 and 1, we will get 0.5. But in case of hyperbolic tangent, we have unbiased average because its minimum value is -1 and its maximum value is +1. Therefore, we will get 0 at the output of the tangent function, the average value of 0 at the output of the tangent function. Therefore, it has unbiased average. So what is the advantage of the unbiased average? So here is the advantage of unbiased average. So what happens when we use this activation function with the hidden layer? The mean of the hidden layer comes out to be 0 or very, very close to 0. Hence, tangent hyperbolic function helps in centering the data by bringing mean close to 0. So what happens when it is used with the hidden layer? Then during the learning of the hidden layer, the data becomes mean centric, which is approximately equals to 0, due to which the learning for the next layer becomes easier and the training of the neural network becomes faster. So what happens instead of sigmoid function, if we use hyperbolic tangent function with the hidden layer, the speed of the neural network becomes faster because it will be easy for the hidden layers to learn. So this is the advantage of unbiased average or unbiased mean. Now, this is the problem associated with the hyperbolic tangent function. That's why it is somehow okay with the hidden layer. The problem is the same as that with the sigmoid function. That is the problem of vanishing gradient. If we see the derivative of the hyperbolic tangent function, so this yellow line indicates the derivative of the hyperbolic tangent function. So at equals to 0, when the input is 0, or at x is equals to 0, its value is 1. But what happens? The gradient becomes 0 when we move in the negative direction and also 0 when we move in the positive direction. So it is 1 when the input is 0. But for the negative inputs, it is close to 0 or it is starting to become 0. And similarly, for the positive value, the gradient becomes 0. Due to which, during the learning, there are high chances that gradients become die out or a vanishing gradient problem occurs. Due to vanishing gradient, the learning of the neural network decreases and it could not generalize well on unseen data. So it has the same problem as that of the sigmoid, that is the vanishing gradient problem, due to which we do not use them so often with the hidden layer. So I hope you understood the hyperbolic tangent function as an activation function. It is somehow the extended version of the sigmoid function, and it has the advantage that it has unbiased average. On the other hand, it has the problem which is same as that of the sigmoid function, that is the problem of vanishing gradient. Thanks for listening, and I will see you in the next lecture.